In this video, you will learn the concept behind logistic regression, including how to find regression coefficients and how to interpret coefficients in a logistic regression model. Let's jump into it. Say you want to describe the target variable y with independent variables x's. You can do so as a linear combination of the independent variables like this. Here, betas are unknown regression coefficients describing the association between the target and the independent variables. This formula works if the target is a numerical variable. But say if the target y is a binary variable, taking a value either 0 or 1, then this model doesn't work since the right-hand side of the formula is never exactly 0 or 1. One possible solution to this is to model the probability of y equal 1, and this is what a logistic regression model does. Here, on the right-hand side is a linear combination of independent variables, x's. On the left-hand side is a function known as a logit function of the probability of y equal 1. Why do we have a logit function here? A logit function takes a value between 0 and 1, thus ideal for describing a probability. A logit function has an S-shape, as you can see. If the input is too small on the x-axis, the output on the y-axis is close to 0. On the other hand, for a large input, the output is close to 1. In between these two, the function gradually grows from 0 to 1. Now that you have a logistic regression model, how can you find the regression coefficients? You can adjust regression coefficients in a way that mismatches between the target and the predicted outcome is minimized, as in many classification algorithms. In the case of a logistic regression model, we describe this mismatch in a function known as a log likelihood function. You can minimize the log likelihood function by adjusting the regression coefficients through a process known as gradient descent. This process produces optimized regression coefficients. Say you found the regression coefficients for your logistic regression model, but how can you interpret these regression coefficients? First, the sign of a regression coefficient indicates the direction of the association between the target and the independent variable x. If a coefficient is positive, then an increase in x results in increased probability of y equal 1. In contrast, with a negative coefficient, an increase in x results in decreased probability of y equal 1. The magnitude of a coefficient, either positive or negative, indicates the strength of the association. The larger the coefficient, the larger the increase or decrease of the probability. Large coefficients may indicate strong association between an independent variable and the target. It also means that the model may be overfitting. To avoid overfitting, a number of remedies are available, including regularization. So far, you have focused on the case where the target is an integer, either 0 or 1, in your logistic regression model. However, in reality, outcome classes may not be an integer of 0 or 1. Target classes may take other values, for example, males versus females or customers versus non-customer. In such situations, you arbitrarily assign one of the classes as 1 and the other class as 0. This way, you can apply a logistic regression model as described above. Often, the class encoded with 0 is referred as the reference category. In this video, you have learned how a logistic regression model is formulated, how to find regression coefficients for a regression model, and how to interpret regression coefficients.